saber agora um pouco mais sobre as redes multinet, né, e a criação dessas redes. Acho que é um pouco isso, né?
Yeah, well, today the multinet is really a unique system. In general, it's multiple opening closing plankton net, consisting of a metal frame with a square mouth opening, and to this frame we attach 5 to 9 net bags, which are opened and closed during the operation, either remotely controlled or pre-programmed. In general, the system is rather unique, not completely unique, but if you have a look at how you can operate it, it's completely unique. Because the multinet is the only multiple opening closing net which you can tow horizontally, obliquely, and also vertically. That's based on the fact that we have lever arms opening the plankton nets, which are spring loaded. So the force we need to open and close is not made by gravity, but it's really made by springs which are stretched manually before the operation. Also, these instruments have quite a long history. The first approach started in the 1970s, and it was based on two different instruments. One instrument was just horizontally towed instrument with a very small mouth opening. We called it multi-shark because the design looked a bit like a shark. And that was an instrument just for horizontal operations, but even it worked fine, but it was with a complete frame also covering the net bags, so it was quite large and heavy, and the handling was not too easy on board. And in parallel, we designed some kind of bucket changing mechanism for vertical standard plankton nets, to have also there multiple samples. And these instruments were produced for some years with, let's say, limited success, simply because both of these instruments had limitations. And that finally, in close cooperation with a variety of end users in Germany, so for example, the Institute of Marine Research of the University of Kiel, later the GEOMA Institute, the Alfred Wegener Institute in Bremerhaven, and also some other international institutions in Norway, and I think also in very early stage in India. We found, okay, we need to have a combined system which covers all potential applications for a multiple opening closing net. And that was the start for designing the multinet that took around about the 1970s until early 80s. At that time, just focused on one size, quarter square meter mouth opening. That was simply based on the fact that for this kind of equipment you do not need a too big ship. It can be operated at ships, let's say from 35-40 meters. But on that system we learned a lot, we developed a lot, so we also started to introduce more intelligent electronics. So in the very first approach it was analog electronics. Also the telemetry was analog telemetry, just indicating the depths and the possibility to activate a net bag remotely, so no programming function, no intelligence. It was really analog electronics, but it worked well. And then later in the early 90s, we started with a completely microprocessor controlled electronics boards, which simply offered a variety of additional options like high accurate pressure sensors, a real digital long distance telemetry, pre-programming functions so that you can program the instrument to automatically do the sampling according to depth. The introduction of electronic flow meters so that you immediately have calculated volume you filter with your plankton net, and the possibility to add other sensors like conductivity and temperature in first step. And well, then the need around, we saw an increasing need for, on the one hand, smaller versions. So we also produce now a version with 0.125 square meters. That's really handy sized. We have a customer in Alaska using it from a 15 meters boat. And on the other hand, we also had requests for larger instruments, especially for the long cruises with larger research vessels. So then we also introduced a half square meter version in close cooperation with the Alfred Wegener Institute and Geomar in Kiel. And I think it was around about in 2012, we were asked by two customers, one from Norway, one from Saudi Arabia, asking for a 1 square meter version. And that was the date where we introduced the biggest one. We call it Mammoth because it's really, for us, it's really heavy stuff. So you're handling in total 350 kilograms of stainless steel on board. Of course, meaning that you need a larger research vessel. So I would say 80 meters or above. We also operated it, especially for testing purposes, on a 50-meter ship in the Baltic Sea. And it worked. But of course, on smaller vessels, the handling is a bit more tricky, simply. But in general, it's really the fact that if you ever have been operating one of the systems, you know how it works. And so you don't need to learn anything new when you switch from a small to the big one. And also with a multi-net, it is really valid that we try to keep it simple for the end user. That also especially is valid for the PC software. So we have our own PC software for controlling the instruments. And this software, I think, is completely different from other software you find in the market of CTD probes. Okay, now step by step, some CTD manufacturers also follow our idea, I have the feeling, simply because our instrument configures the software at the PC. So you don't need to handle any configuration files. You simply connect our instrument to the PC, and the instrument is able to tell the PC, okay, I'm a multi-net, I have 9 net banks, I have a pressure sensor with a depth range of 6,000 meters, here are the calibration coefficients, I have a conductivity sensor, etc., etc. So automatically the PC software displays what you can do with the instrument, and not more. On the other hand, you can use one software, the identical software, for all of our instruments, simply because connect the instruments and then the software knows, okay, what's going on. Yeah, and I think really the main thing is, on the one hand, the combination of horizontal, oblique, and vertical towers, and the reliability of the instruments. So far, I don't have the exact number, but approximately 240, 250 systems have been sold so far. And we are currently producing a couple of them for Taiwan. It's a quite nice project, which, well, the instruments will be delivered, I think in October or November, and hopefully next year other multinets for Taiwan will pop up. Yeah, it's quite nice because Taiwan is currently renovating or replacing their fleet of fisheries research vessels, and of course one of the very important applications of the multinet is fisheries research.
Realmente as multinets aqui no Brasil também são um sucesso e todos os navios de pesquisa, seja de universidades ou até de grandes empresas, têm buscado ter esse equipamento aqui. É realmente muito interessante. Fala também um pouquinho sobre os equipamentos para coleta de água, né? A Rosette é muito procurada aqui no Brasil também. Um pouquinho da diferença dele e também sobre os analisadores com fixação automática in situ, que são uma novidade, né? Não tão nova, mas que tem bastante potencial e pode vir revolucionar essa parte de coleta de água no ambiente, principalmente marinho.
Well, for water samplers, it's the same as for all other product groups. So we always start on the lower end with simple mechanical instruments. So for the plankton net, it's really simple ring plus net bag plus net bucket. But on the other hand, we always besides the variety of very basic water samplers, we also have some more sophisticated or intelligent samplers. For example, we have a so-called integrating water sampler that automatically provides depth integrated samples. That's a design mainly based on the European Water Framework Directive. It's used in all rivers and lakes, or mainly lakes in the EU. But we also have multiple oceanographic multiple water samplers or carousels. Well, in principle, a carousel is simply an arrangement of standard Niskin or free flow water samplers. In our case, the frame is completely made from stainless steel, simply because it's much more robust. And then we have a release mechanism, which in our case is extremely reliable because we choose design which is very simple. Sounds crazy, but simple is reliable. And as I said, the worst thing that can happen is you are out at sea and your instrument doesn't work and you lose time and data. So in our case, the release mechanism is motor driven, so really with gear wheels, etc. In contrast to competitors who have an electromagnetic release, which requires quite some maintenance and which also tends to failure. For our systems, for our carousels, the only maintenance you have to do is rinse the instrument with fresh water after use, let it dry, and then you can store it. And from time to time, you replace the batteries or you use a rechargeable battery pack. Why do we have batteries? Well, simply due to two reasons. One reason is our carousel is really ready to use when you order it. So when you order a multiple water sampler from Hydrobias, you get an instrument which already has a pressure sensor inside. It has data storage, it has long distance telemetry, so you always have a combined online-offline system which you really can use. You do not need any additional equipment. Competitors sell you a carousel, but the basic carousel is more or less useless because you just can program it according to time in case you order a battery pack in addition. And so to operate these third-party carousels, you always have to add a quite expensive CDD probe. And if you want to operate it in online mode, you have to buy additional equipment for telemetry, etc. And simply because our instruments are always operating online and offline, we always have a battery pack because in offline mode we need the battery batteries to operate the system, and on the other hand, by also in online mode using batteries, we are increasing on one hand the safety for the operators, and because we just have 5 volt at the conducting cable, so that's really safe. Competitors use up to 400 volts at the conducting cable to power the instrument over 10 kilometers of cable. And the second advantage with this battery powered instrument is that the requirements for the conducting cables are extremely low. We are talking about cables of 10 kilometers having quite some electrical resistance. Competitors, and at normally 300, 400 ohms cable resistance, we can survive up to 1 kilo ohm. And that's really important because the electromechanical cables are really under extreme stress. They are always bent in all directions, meaning that the copper, the isolated cores, start breaking, and the breaking of the core simply increases the resistance of the cable. And well, if you just can survive with 400 ohms of resistance, you much earlier have to replace the conducting cable, which is quite an investment. So also there we have a higher reliability, so really the both biggest advantages are safety and reliability. And when it comes to adding additional sensors to the standard pressure sensor we always have, is that we directly integrate sensors into the motor unit. By the way, the material of the motor unit is always titanium for high stability and extremely high resistance against corrosion. So we do not add external components which you somehow have to plug together. We really start to integrate the sensors into the motor unit. The sensors itself we do not produce on our own because there is a variety of really good sensors available worldwide. So we buy the sensors and integrate them and do the data handling on our own. Also analog electronics. So for example, for conductivity and temperature, we just buy the cells and we do the analog processing and the digitization of the data on our own, which leads to the fact that our data are more accurate than the data of the manufacturer of the measuring cells in some cases. That's fun fact, but it's true. And then besides conductivity and temperature, we can add additional sensors according to customers' requirements. We can also add external sensors. So for example, if a customer has very good experiences with a specific sensor, let's say fluorometer or an optical oxygen sensor or whatever, just let us know, then we can check how we can integrate it. Normally it's no problem. Simply we have to check with the manufacturer of the sensor the protocol or the analog specification of the sensor and the mathematical model, and then we can integrate it. So far we have been integrating, let me see, well, just give you some examples. 2 or 3 different oxygen sensors, turbidity sensors, chlorophyll fluorometers, pH, well, I think that's just to give you an idea. But if you or if your customers have a specific requirement, just let's talk about it, because we have it all in our hand. We really handle all technical things, and so we can also do this kind of integration. Yeah, the number of samplers we can handle in our carousels is 6, 12 or 24 bottles. smallest sampler size is 1 liter, biggest sampler size is 10 liters. And we do not only provide, or we do not only integrate the standard Niskin bottles, but also a modified sampler, which we call free flow sampler. That's a design based on requirements from customers who do regular sampling with a carousel and who did not want to stop for each closing process, because the traditional Niskin bottle has a cone, and that simply reduces the water exchange. And this customer made a lot of tests and could figure out that if you pull up the instrument with approximately 0.5 to 0.7 meters per second upwards and close the sampler, the water inside after closing represents a water approximately 2 meters below. And therefore we modified the Niskin principle that we simply remove the cone and have a larger lid, so that's really a free flushing, free flowing tube. So in principle it's the same design, but of course it's a bit longer. The samplers are a bit longer because the wall thickness need to be higher for more stability, because we don't have this cone for stability. Yeah, in general we have a variety of standard arrays, standard sizes, but even if a standard size does not fit, for example, you have very tight space on board, then we also can modify this, and the modification does not cause heavy extra costs, because in times of computer-aided design it's rather fast to scale up or down an instrument and also to create the drawings, etc. And so we don't really invoice a huge amount for these modifications. Standard depth range 3,000 meters, optionally 6,000 meters. That's just a question of the raw material for the pressure housing. The 3,000 meter version is made from titanium grade 5. That's pure titanium. And for the higher depth range we use titanium grade 5. Yeah, so standard is grade 2, and for higher pressure we use grade 5. And that simply leads to the fact that the surplus price for 6,000 meters is rather high, because in grade 5 no tubes are available. You just can buy solid bars, and that means you have a lot of machining time, especially to get the first hole into it. And that's why we really just use it when needed, simply because it really costs a lot of machine time. Yeah, I think that's it about the carousel samplers. And last, a short introduction in the in situ fixation sampler. What is the background? The background in first approach was that scientists at the Institute of Baltic Sea Research in Warnemünde in Germany wanted to study the bacterial community in water samples, but they not only wanted to see or to analyze the species they find, they also wanted to assess the activity of the bacteria. And for that purpose they had the idea to use the transcriptomes, the mRNA of the bacteria, to assess their current activity. But the main problem with mRNA in this case is that it really degrades fast if you have environmental changes. So the change of mRNA can be, depending on the species, can be as fast as 10 seconds or something like this. Meaning that if you close a water sampler and then pull it out, during pulling a carousel upwards, you have decompression, you have temperature decrease or increase, and that can completely change the behavior, the activity of the bacteria. And therefore, they said, okay, we need to somehow fix the sample in situ. That's something, especially in view of mRNA, nobody did before, because it's not as easy as it might sound. It's easy to fix DNA, because DNA is quite stable. But to fix mRNA is really, really tricky. And in first approach, we tested a variety of fixatives based on chloroform and other toxic agents. Of course, we need toxic substances. And finally, we had good results for short-term fixation with phenol-based solutions, a so-called sub-solution. And based on that, we designed so-called APHIS, the automatic fluid injection sampler. That's a sophisticated machine which goes into the, which is mounted inside a carousel, and so it's triggered like any other water sampler inside a carousel, but then it has quite some electronics and then also mechanical components inside. So we feed the fixative with an infusion bag mounted at the sampler. And when the sampler goes into the sea, we have a sealless ceramic piston pump who feeds this fixative into a pressure vessel so that we can inject the fixative with a quite high pressure of up to 7 bars. That's needed that we can fix the sample within some seconds. And also the distribution of the fixative is quite tricky. If you have a water column of let's say 50-60 centimeters, you need to evenly distribute the fixative, and it worked really good. We have users so far in, well, of course, Germany, so the Institute of Baltic Sea Research in Warnemünde uses them. We have customers in Norway and in China, but as it is always the fact with new instruments, it takes time. Everybody is interested, and then, okay, who is using it? I need to see the papers. Yeah. So, give me the proof it works, and what can I do with it, etc., etc. So, it's always a long-lasting process, but that's not a big issue for us. We know that, so we go for the long run. Well, and afterwards, when this technology was working quite fine, the colleagues in Warnemünde said, okay, now we have a ship-based system. That's really, really good. But what about an autonomous system we can deploy on a specific spot, which can take samples when we have some special events? Especially for the Baltic Sea, it is interesting. We regularly, but unpredictably, have an event that fresh seawater from the North Sea, especially during storms, feeds into the Baltic Sea, and that's the seawater from the North Sea has a higher salinity, so it goes below the Baltic seawater. And additionally, we have few very interesting areas in the Baltic Sea, some oxygen minimum zones, which go down to 170 meters. The average depth of the Baltic Sea is 40-50 meters. And so, of course, it would be extremely interesting to see what happens in these oxygen minimum zones when this fresh water enters. But you cannot predict it, so you cannot be there with a ship. And therefore they ask us, okay, can we design an instrument which can automatically take the samples? And that's something we currently do. That's an instrument we nowadays call APHIS-SYS, so an automatic fluid injection system. But that's really a thing for the long run, because we have additional applications. And to summarize, the idea for the really, really, really long run, so I'm talking about, let's say 10, 15 years, is that we are, hopefully someone will be able, that you just have to take one sample based on this fixation technology, do just one analysis, so deep sequencing of DNA and mRNA, and with the results you hopefully then get a complete overview about the conditions of your water body. Physical data, so you will be able, based on also the bacterial activity, you will be able to detect an approximate water temperature, salinity. You will be able to detect explosives. That is what still works. So TNT detection is possible. And we are aiming to extend this to a lot of other parameters like nutrients or UV filters or whatever. But for that purpose, we need to, or especially the scientists need to gather a lot of data, because they need to understand the connections between specific bacterial activity to specific physical conditions or chemical conditions, etc. And therefore, we are joining forces under the umbrella of the so-called Ocean Technology Campus in Rostock, with a variety of institutions and companies to gather the data and to evaluate the data and to create some kind of database where you find these connections. And that of course involves also artificial intelligence, because if you do a deep sequencing, you are not able to just analyze it by manpower. So the Fraunhofer institution is involved, a specialized company for artificial intelligence is involved, and they joint action shall lead to more or less automatic analysis and the automatic finding of these connections between bacterial activity, bacterial species, and the environmental conditions. And last but not least, this automatically will also provide data of environmental DNA. Just because we also catch it, we analyze it, and so add on. But as I said, it's for the long run. I think we are talking about 10, 15 years. Hopefully not more.
Bom, nossa, que aula, que aula. Queria muito agradecer essa conversa, uma aula de oceanografia, de instrumentação oceanográfica, de técnicas de coleta, de entender o ambiente, entender o cliente, né? E também uma aula de negócio, porque uma empresa de 100 anos e a forma de pensar e ainda assim inovando, poxa, foi realmente uma aula. Queria muito agradecer você, Julian, por estar aqui com a gente, por ter compartilhado todo esse conhecimento e todas essas informações com a gente. Espero que você tenha gostado.
Let me conclude also with a big thank you to you here at Hidromares. First, it's really good to have you here. We're looking back on, I don't exactly know how many years of cooperation.
20 years.
So also long history, and a successful history. Without our regional distributors, we are nothing, because simply in some areas, in some countries, on one hand we have probably language problems, or we have problems to understand how business works, or it is tricky to handle all customs details remotely, etc. And last but not least, of course, you have the short connection to the customer, so it's also a benefit for the customer that he does not have to wait until we are up in Germany when he has a problem. He simply can say, okay, now it's 8 o'clock in the morning, I can call Hidromaris and ask, okay, I have a problem, I have a question. You can directly act. So first, let me thank you for this long-lasting cooperation. Second, thank you very much for the invitation to be here in Brazil and also to be here for this talk today. And yeah, final statement, it's a great pleasure to be in Brazil. Thank you very much.
Ok, então, gente, quero agradecer a presença do Julian, a presença do Gabriel aqui, né? E agradecer essa oportunidade de você estar aqui junto com a gente, com o nosso podcast. E também desejar aí que todos apreciem, assim como a gente, essa conversa, né? E todas essas informações incríveis que a gente teve aqui da Hidrobios e do Julian e da história dessa empresa, né? Então, muito obrigada a todos. Assistam o nosso podcast e apreciem junto com a gente tudo isso. Então, vamos fazer o encerramento aqui, né? Mas que a gente termina mais um do nosso Oceano em Foco, podcast aqui da Hidromaris.